Okay, class, we are actually at the last lesson for first semester. Okay, so lesson 6.6 is the last melon as we finish up first semester and get ready for the final. So, mixed expressions. Now, here's what Mr. Snowman says. What is a mixed number? Do you remember what a mixed number is from math past? Yeah, that's right. It's a whole number with a fraction. Okay? Well, we're used to seeing those in math, but when I'm talking about mixed expressions, when I'm in algebraic fractions, what does that mean? Well, we're going to find out that a mixed expression is the sum or difference of a polynomial and a fraction. So if you look here, I've got a constant term plus a fraction. Okay? If you look at my second one, I've got fraction number 1 minus fraction number 2 plus a constant term. So we're going to see then the mixed expression is I've got fractions and I've got polynomials. Now, because it's saying that I need to do the sum or the difference, well, what did we learn back yesterday when we were dealing with 6.5? How do we add or subtract fractions? That's right. I've got to come up with a common denominator. So, pretty much what we're doing today is very close to what we did yesterday. So I kind of broke it down into 3 steps. Step number 1, it says to simplify a mixed expression, we're going to have to find the LCM, okay, or the LCD. So that's what we did last night. Okay, we found the common denominator. And then step number 2, we're going to rewrite them. If you remember, Mrs. Burton was calling that getting our equivalent fractions. Okay, so we're going to find our equivalent fractions. Okay, and then we're going to have to do the math and write the answer in simplest form. And again, that goes back to section 6.1. We've got to make sure that if I can factor something, I need to. So remember, part A of that was factor, and then hopefully something would cancel. We're going to see they actually, in this last section of chapter 6, they put everything we've learned in chapters 5 and 6 together into one problem. So let's look at problem number 1. Now, what I like to do, I take my polynomial and I put it over 1 so I can see that. So if I'm looking at number 1, and the name of the game is subtraction, if I look at the sign that's in the middle or in between them, so before I can subtract, I have to have a common denominator. Now to me, this is a little bit easier because there's really only one option for a common denominator. Well, the only denominator I have is x, so my common denominator has to be x. Now, my second fraction right here, he's already got the right denominator, so I don't need an equivalent fraction, but I have to come up with an equivalent fraction for the first one. Now, let's look at my original. We're going to look at the original denominator and the new one. What's missing? Well, obviously what's missing is my x, so we're going to multiply the numerator by x, and so we get 5x times x is 5x squared. Now, I've got a question for you. What's 5x squared minus 3? Yes, it's 5x squared minus 3 over x. Now, I'm going to ask this question a lot. Are we done? Have we simplified? Well, if I look at my numerator, I don't have a GCF. I don't have any like terms. Okay, can't cancel anything out. So this is my final answer. Now let's look at number 2. If we look at number 2 and I put my constant term 8 over 1, the name of the game is addition. That's the sign in between. So if I'm going to add them, then I need a common denominator. What's my only choice for a common denominator? Yes, between 1 and y minus 1, it's got to be y minus 1. All right. So I know my second fraction is already good because that's the right denominator. Now, between the original And my common denominator, what's missing? Well, y minus 1. So it's got to be 8 times y minus 1. Now, this time, I do have to take care of that distributive property because I'm going to have to collect like terms. So we've got 8y minus 8 plus y. Again, Mrs. Burton puts all her numerators together over y minus 1. Is there anything I can do in the numerator? Yeah, we've got like terms. Did you notice that? We've got 8y and positive 1y, which gives me 9y minus 8 all over y minus 1. Now, and that's my final answer. That's a y. Okay? Final answer. Okay, let's try another one. Let's look at number 3. Now, I want everybody to try number 3 on your own. And if you try number 3 on your own, let's see what happens. Yeah, can you figure out what my common denominator has to be? All right, I'm going to show you the right answer, and let's see how you did. Okay, again, my common denominator had to be A. If you look at my number over here, my equivalent fraction is here. And now I've got to subtract the numerators. So, final answer's in the red box. Everybody try number 4. Everybody try number 4. What's my only choice for a common denominator? Yeah, it's got to be y plus 2. Okay, let's go ahead and work on that one for a minute and we'll check our answers. Let's go ahead and pull Mr. Snowman out. And so if you look here then, my common denominator's in blue. It had to be y plus 2. All right. And then I had to take care of my distributive properties. So y cubed plus 2y squared. Remember, we're subtracting back here, so this becomes negative 3y minus 1, because to subtract, I have to add the opposite all over y plus 2. And again, there's a lot of y's there, but there's no like terms because they all have different exponents. All right. Now, let's all look at number 5. When I look at number 5, this time, Mrs. Burton calls this a threefer. We've got 3 separate terms here in my mixed expression. So I need to subtract them if you look at what's in between. So if I put this over 1, the good news is my other 2 fractions have a common denominator. It's y plus 2. So that has to be my common denominator. We've got y plus 2. And then for the numerator here, did you realize I've got to multiply that by y plus 2? Minus, let me go ahead and Ms. Burton write everything down. My middle fraction stays the same because it's got the right denominator. And my third fraction stays the same because I've got my common denominator. Now, let's look at our numerators. Let's do the math in the numerators so we can combine like terms. So we know y times y is y squared. And then we've got y times 2 is 2y. Ooh, did you see my minus sign here? We're multiplying, could be red flags waving, so that's going to give me negative 4y, and negative 4 times 1 is negative 4, and then we've got our final fraction right here, minus 4. All right? So, all of that's going to be over y plus 2. Now let's look at our numerator. Do I have any like terms I can put together? Well, the y squared is going to come along. We've got y squared. We've got 2y and negative 4y, which is negative 2y. And then when we put negative 4 and negative 4 together, we have negative 8 all over y plus 2. Now, here we are. Is that in simplest form? Look at that numerator. How can I simplify the numerator? How many terms are there? 3. That's right. Guess what? We're going to have to X factor that numerator. Chapter 5 still lives. So we've got y minus 4, and we've got y plus 2 all over y plus 2. It's important to realize that we had to X factor because now the y plus 2's cancel. Mrs. Burton went the long way home here, and my final answer is y minus 4. Good job. Okay, let's try another one. Now, when I look at number 6, this is the last one for today. When I look at number 6, what is my common denominator? Is there anything common to both? Remember, this x plus 1, this binomial, is different than this x, which is a monomial that stands alone, and then this 2 is over 1. So when I look there, there's really not anything common to both. So what's my common denominator? Yes, everything funnels down, everybody comes to the party, so x plus 1 is my common denominator. Now, I've got to get 3 equivalent fractions this time, okay? And so this is x times x plus 1. So let's look up here. If I look at the first fraction, we're looking at fraction number 1, I've got my x plus 1 and x plus 1, so we're going to multiply the numerator by x. Remember how we get our equivalent fractions? When I look at fraction number 2, I've got the x and the x, but I'm missing the x plus 1. So that means this is going to be x plus 1 times x plus 1, which is x plus 1 squared. And then when I look at the last fraction, number 3, well, I need everybody, so we're going to say 2 times x plus 1. Now let's go back here. Hopefully you know x times x is x squared. Now, let's see what happens in our numerator. Okay, well, we know we've got x squared. Now, here's the deal. This guy right here, did you realize that that means, let's go put this over here, that means x plus 1 times x plus 1. When we were back in chapter 5, you either knew the special pattern or we foiled those. So we've got a minus sign in between it, and if I FOIL those two, I'm going to get x squared plus 2x plus 2. And then we've got a plus sign, and the last fraction, we're just going to do our distributive property. Okay, now, because of this minus sign here, we're going to have to change everybody's sign. So this is going to be x squared minus x squared minus 2x minus 2 plus 2x squared plus 2x all over that common denominator. Now, let's look at our numerators. What can I do? Okay, do you see some like terms we can put together? Yeah, good. X squared minus x squared cancels out, but we still got this 2x squared, so let's go ahead and bring him down here. And then if you notice, we've got negative 2x and positive 2x, so they cancel out, and I'm left with this. I messed up. This should be a 1. Okay, and this should be a 1, so this should be minus 1 all over x times x plus 1. Okay, did you see where Mrs. Burton made the mistake when I FOILed? It's supposed to be 1 times 1, which is 1, and I added them. Shh, don't do that. Okay? Now, so when I made that change, now I've just got the negative 1 left, and so that's my final answer. So if you notice, they put everything together that we've done in chapters 5 and 6 in one problem. So you've got 10 problems for homework, and we'll review tomorrow for the test. Great job.